All right, well, let's see if you got it. It's negative down here, right? That means to the left of -2. It's also negative between 0 and 2. So this is the correct answer over here. And I'll blow that up a little more too. That should be your answer. Yes?
You have a parentheses where you don't want to include it. However, on the 2 and up, why is that not a bracket?
On the 2 and up?
Like on positive, you use a parentheses because it doesn't include the number itself. But like on infinity, why would it not be a bracket on that?
For the same reason that at 2, at the value 2, right? It looks like I have an x-intercept, which means that my function's value is 0 there. And 0 is not a positive number. So if you try and include 2, you're telling me that at 2, when I plug 2 into the function, I should get a positive number.
What about the infinity?
What,
Because that infinity would be included, wouldn't it?
Great question. Infinity isn't a number. That's the idea. That's the reason. If you put a bracket on infinity, you're actually saying that you include infinity. But infinity is an idea. It's an idea of going further. So we always put parentheses on it regardless. Yep. You'll never have a bracket on infinity or negative infinity, both ways. Good question. I almost mentioned that, but I just was going to let it go. I'm glad you brought it up. All right. Oh, there's one more there. Where is the function equal to 0? Where is it equal to 0? At -2, 0, and 2. How do you write that? What's the correct way to write that? Do you do brackets? You're trying to include it, but it's only one point, right? So here's where we have to understand some notation. Brackets and parentheses are for intervals. That's when you're trying to say between this number and this number. But if you only want to include what we call a singleton, a single value, you use braces. So let me show you. Here's where it's equal to 0 at those 3 points. And I'm going to have to blow this up so we can see it. So what I put is x is an element of the brace. The first brace means a set of points, not an interval, a set of points. And the set is -2, 0, 2. Close the brace. Now it would not be wrong to do this though, also, just so you know. You could have put x is an element, or sorry, you could say something like x equals the single value -2. And you could write x equals the single value 0. Those are my braces. Sorry, they're terrible. 2, like that. You could write them individually. But then you don't say element of, you say equal to. It's equal to that single value. Element is if it's coming out of a set or an interval. Is everyone still awake? Everyone all right? Okay, so that's the idea of positive, negative, and 0, right? So what does it mean for a function then, not to be positive and negative and 0, but increasing and decreasing? Well, increasing means, and this is the actual strict definition of what it means to be increasing. A function is said to be increasing on an interval I if f of x sub 1 is less than f of x sub 2 when x sub 1 is less than x sub 2 on the interval I. What? Okay, and it's decreasing when f of x sub 1 is bigger than f of x sub 2 when x sub 1 is less than x sub 2 on I. All right. What does that mean? It's kind of, I mean, there's a relationship between those points. What does this first one say? Increasing means that this point is what? The height of that point is below the height of the next point, right? And the first point is on which side of the second point? If I say x1 is less than x2, I'm saying x1 is to the left of x2, right? So that means that the point to the left is below the point to the right, correct? That's what it means to increase. Decreasing means the point to the left is above the point to the right. Now, you're going to see this in a picture in a second. And constant means what? They're the same. The heights are the same. So let's take a look at the picture. Oh, I went too far. Okay, so I gave us 2 points here. Here's x1, and here's x2. All right? x1 is to the left of x2. Now, what's the relationship between the heights? Which one is bigger? Ooh, this is tricky. Which of these is bigger? The left one or the right one? The right one is bigger. Because you have to remember what a number line looks like, right? Remember with the number line that when we say here's 0, right? Here's -1, here's -2. Which of those numbers is bigger? -1 or -2? Which one's bigger? The larger number's to the right. Now, if you take the absolute value of the number, then okay. So it's a little tricky on this graph to realize that even though this is a smaller height, this number, -2.1 or whatever that is bigger than -6.3. So would we be increasing or decreasing here? If the point to the right is bigger than the left, it's increasing. Now I also put a little thing here. You can click arrow that connects it with an arrow. Hey, doesn't that arrow point up? That's what we mean by increasing. All right. So if we ride this thing like a roller coaster, and just like we read a book, we always read left to right, correct? We always read left to right. So if I sit here and I read this thing left to right, I'm going up, right? I'm going up, I'm going up. The roller coaster flattens out here, right? Just for a second, flattens out. But then the roller coaster goes up and up. And the arrow is actually getting longer, which kind of represents the idea that it's getting steeper, right? All right. That's increasing. Now, what does decreasing look like? Roller coaster, riding it from left to right, but now we're going down, right? The point to the right is smaller than the one to the left. If you put an arrow between those two, you're going down. What about at 0? We haven't addressed this. What's happening at 0? This is very critical. Think very carefully about this. What's happening at 0? It looks like it flattens out, like it's constant, doesn't it? But when you talk about increasing and decreasing, you have to be looking at an interval. So let's say you're picking one of your points. I'm going to come up here on the board. If I pick, let's say, 0 to be one of my points, then I have to pick another point either to the left or to the right. If I pick one to the right, I'm going to be down a little, aren't I? And I'll still be decreasing. If I would have picked the other point to the left, I would have been up. So I still would have been decreasing, wouldn't I? So when you talk about increasing and decreasing, you cannot talk about increasing and decreasing at a single point. Can't. Has to be, you always have to be testing 2 points next to each other. So at 0, you can't say what's happening at 0. You just can't. You can't say, is it increasing or decreasing at 0? What you can say, though, is that this is increasing, or sorry, this one right here is decreasing everywhere. Would you all agree with that? No matter what, no matter where you are on this graph, you're always going to be going down. And then a constant function is kind of less interesting. It just stays the same the whole time, right? So your arrow is flat this time. Doesn't go up, doesn't go down. With me? All right. Determining where a function is increasing, decreasing, and constant. So let's go back to this. I'm going to put this example up here. See if we can get this numerically. Now let's make sure we can see these marks. This is, if I try and blow this up, let's see. Oh yeah, that's a little better. Okay. where is this function increasing? Where is it increasing? So if you're riding this roller coaster from left to right, where is it going up? And just like we did with positive and negative, you're talking to me, you're telling me your answer in terms of the x values. So from where? -2. You're saying the x value, -2? To where? From here to here, you're going up? Do you all agree with that? I agree that, yes, that's true, but there's more. Like over here, aren't you still going up also? Right? So everywhere over here, you're going up. All the way until you get to what x value? -1. So from -1 to the left forever, your function was increasing. Where else? From 1 down here, right? So at x is 1 to forever to the right, it should be going up. Yes? Good question. It's not incorrect to put a bracket, but I always tell my students, put a parenthesis. So I'm going to show the increasing now. So I click on increasing, and it brings it up. The dotted part is where the function's increasing. So everything over here, then everything over here, and then the red, what does the red represent here on my x-axis? That's my answer, right? Now, it looked like -1, didn't it? It looked like -1? It actually wasn't, sorry. We'll just say it was -1, but it was -2 over √3. That's where this value is. And then this is 2 over √3 is here to infinity. Do you see how my answer is represented? Parentheses on everything. For increasing, decreasing, just always use parentheses. So where's the function decreasing then? Where's it going down? Yeah, I mean, we can still say -1. All right, that's fine. From here, though, right, down until I get to here. So if we stick with the 1 in -1, we could say from what, -1 to 1? Or if we use what those values are, it would be from -2 over √3 to +2 over √3. And that would be also parentheses on both. So there, that would be my answer. And lastly, where is it constant? It's never constant. So how do you say it's never constant? How do you say never? What's that? DNE says does not exist. That's a little different. Does not exist is we reserve that for when we talk about limits of things, which we're getting to, just not yet. The empty set. The empty set. A 0 with a line through it at a little angle is the empty set. It's the set of nothing. Now, again, this is just a little side note for everyone here. Let's look at this. What's the difference between this and this? The top one is a number. It's the number 0. Okay? The bottom one is the set of nothing. So let's say I had a red basket sitting here, right? And inside of it, I put that, right? How many things are in that set, in that basket? One thing is in that basket. What's in that basket? The number 0, okay? If I say here, this basket right here, how much is in that basket? Nothing, okay? So 0 with the line through it is a set. It's the set of nothing, as opposed to the number 0, which is the number 0. Completely different concepts. It's dogs and oranges. They're not even the same type of thing. A set versus a number. Now, I know in the military, I think the military, they do teach to do is a line through the zeros, so you don't mistake it with an O, right?
Phonetically speak out 0. You don't say, oh, it's a number, you say 0.
But if you write it, don't they usually say to strike your 0 or strike your O or something like that? Okay.
Preferential.
I've heard it, people tell me from military, like, oh, that's what we use for 0 or something like that. That's right. It's all about context here. So in this class, don't ever give me an empty set for 0 as your answer. If your answer is 0, you put 0. But don't put 0 in a line through it, because that means the set of nothing. All right. So it's never constant. Let's try and determine the domain of a function algebraically. Oof. Determine the domain of these functions algebraically. So you have those written down, right?